Hi, I am Cadet 2nd Lieutenant Larissa Ragain. I'm from the Thiele Squadron, and I will be introducing our project from our squadron. It will be measuring audio transferability, air temperature, and pressure at high altitude.
Hi, I'm Senior Master Sergeant Scott Gers from the Thiele Squadron, and I'll tell you the objectives and the hypothesis. And the objectives were to measure audio transferability at high altitude, as well as the altitude and the air temperature, and the pressure. Our hypothesis was that they were correlated and that the function of altitude will influence the audio transferability.
Hi, my name is Staff Sergeant Harris, and I'll be explaining the materials tab. Our housing was a 50 milliliter centrifuge tube with a lid. For our sound sensor, we used a Commodox AVR PIC sound sensor. It sends decibel levels and sent that as a analog signal to the microcontroller. For our temperature and pressure sensor, we used a BMP-180 Adafruit. For our battery, we used 4 A23 batteries. They each produced 1.5 volts. And for our wire, we used 1/8 inch copper wire. We used a on-off switch on the housing for easy access to on-off. For our microcontroller, we used a Arduino Nano Every, and we used part of a glove for the rubber ending on the end of the centrifuge tube.
And our background was we added multiple changes to the project we used last year, including more powerful batteries, a buzzer, and a decibel sensor. We also removed the magnometer. The changes were made to measure the transfer of sound in relation to the given altitude.
And I'll be explaining the testing method tab. For our sensors used, we used a BMP-180 temperature, moisture, and altitude sensor, and our AVR PIC sound sensor. For our pre-launch testing, we did testing on each individual sensor, as well as the code that brings all of them together. I ran in real life test with the batteries and such, and for our post-launch results, the wires attached to the on-off switch were disconnected, and the pins connected to the buzzer were unstable and or disconnected. And I'll be explaining the results tab. Our mission data, we were on Balloon B. Our peak altitude was 100,318 feet. Our launch date was on October 5th, 2023, and our SD data, we didn't collect any data from our micro SD card because our project was unfunctional, and our equipment data project was damaged. The wires observed to be disconnected from the on-off switch that connected to the microcontroller, causing it not to have any power.
Are the implications of results. Our objective is skewed because we did not receive any data due to broken wires on receival of the project. Our hypothesis was unable to be proven due to the lack of data, and the cause of damage is unknown to us at the time. Our results are we need to optimize our design and continue testing in order to prevent damage in future application.
Hi, I'm Cadet Senior Emily Weinhold. I'll be going over conclusions and discussions. The lessons learned from our project is in future years, we shouldn't attach the power switch to the cap, and our team should provide more information to the launch team to prevent damage during launch inspection. For future directions, our immediate next step is to repair electronics, and the design needs modified to withstand pre-launch inspection. I'll be going over acknowledgements. We would like to acknowledge Thiele Composite Squadron members, Senior Member Advisors, Southeast Missouri State University, and Nestlé.
So for the batch design, I did the Missouri flag, I did a trail for the Trail of Tears, the Mississippi River, and high altitude balloon for the high altitude balloon challenge. We are going to split the money for aerospace education membership for all the teachers in our area because 20 to 22% of people are living in poverty in our area, which is double the state average. We are also going to use the money for aerospace trips.